Today, we're going to do an introduction to linear regression models in a software program referred to as PACER. PACER is a web-based application that makes data analysis, specifically many psychometric analyses, very easy. Because it's a web-based application, you don't need to install any software. Simply head over to the link, which is available here, or you'll see the link available in the comments, and you'll come to the landing page. The landing page is just like any other landing page you've ever seen. It's very simple, and it describes the features that are available in PACER. In the top, you'll notice a navigation bar. If you click on the navigation bar, you head over to the different modules. These modules are the different tools that are available in PACER. You'll also notice there's a Help tab. If you click on the Help tab, in particular for today, we use linear regressions, so I'll head over to the linear regression help. And you'll find a little bit of background that describes the type of regression models that are available in PACER. You'll find a tutorial which describes a complete example of how to run a linear regression using the PACER software, along with helpful screenshots. And you'll also find the technical details that describes the mathematics that are being used to implement the type of regression model that's available in PACER. Today, we'll use these data available under the tutorial. Simply click on this link and download the data file so that you can follow along. However, you can actually use any data file to run a linear regression in PACER, as we'll see. To begin, let's head over to the regression module. And let's choose linear models. The first thing that we need to do in order to run a regression is to read in our data file. Let's do that. We can choose either a CSV file, or we can even read in an R data file. Simply toggle between the two. Let's read in a CSV file, the one that we just downloaded from the tutorial. We'll click here. We'll download this file, MM. If you had another data file with another type of separator, just click on the read-in options and choose the type of separator that you have in your data. So how do we know if our data file was read in? Well, let's click on the View Data, and this will produce a simple table showing us the data file that we just read in. For now, we have a dependent variable, which we'll refer to as y, an independent variable x1, another independent variable x2, what psychometricians refer to as a conditional standard error of measurement. We'll call this SEM1, that's associated with x1, and SEM2, that's associated with x2. These data also follow a hierarchical structure with a student ID, a school ID, and a teacher ID. These data show that student 1 is nested in teacher 1, and teacher 1 is nested in school ID 1, and so on. We could see more by clicking on Show. Perhaps we click on the first 30 observations, and we see we have more teachers, more students, and in this particular view, we only see school 1. Also notice there's teacher 2 and teacher 3, which we'll ignore for now. But as a note, PACER also makes it very easy to run multiple membership models. These tables are searchable and filterable so that you can easily find things that you're looking for. You can also export these tables by clicking on any of these tabs here. Let's head back over to the regression model, and let's run our first regression. The first thing we'll do is click on Options. For now, we'll choose Y as our dependent variable. And let's do something very simple. Let's choose X1 and X2 as our independent variables. For now, let's not do anything more. Let's leave all the defaults alone. And let's click Run Regression. The regression model is running, and we see the results printed to screen. We have our labels, we have an intercept with an estimate, a fixed effect for x1, and an estimate for the fixed effect for x2. Standard errors, t-values, and p-values. Of course, we also have our fit statistics, the root mean squared error, the degrees of freedom, and the r-squared. And we have a very nice plot here, the residuals, plotted against the fitted values. This plot is interactive. You can export this plot by clicking on the camera. And you can zoom in on particular points by taking your mouse and clicking and hovering over a zone that you want to see more closely. And notice we now see those points. If I move over to regression model plots, I now also get the theoretical QQ plot, which plots the fitted values against the theoretical quantiles. Again, these plots are all exportable and interactive. Now, there's nothing special about the regression model we just ran. In fact, we don't need special software to do what we just did. But PACER implements a very special type of regression model known as an error in variables linear regression, or an EIV regression. If I come over here and I hover over the I, notice that's a tooltip. It tells me a little bit about what this option provides. Let's now assume that my independent variables are imperfectly measured and that they are measured with some error. Let's click Yes in order to run an error in variables linear regression. Notice now, PACER is asking which independent variables have measurement error. Let's choose both x1 and x2. Now, PACER is asking, what's the type of error correction? A heteroscedastic or a homoscedastic? We happen to have the conditional standard errors of measurement. So let's use those. I'm going to choose SEM1 and SEM2. If I didn't have the conditional standard errors of measurement, I could click on homoscedastic, and I could enter the reliability of the individual measures. We could say x1 has a reliability of 0.87, comma, variable 2 has a reliability of 0.92, or whatever it happens to be. Let's go back to heteroscedastic, and now let's run the linear regression by clicking Run Regression. Now we have our results. This is an error in variables, linear regression. The same things are printed to the screen as before, but now we, in addition, have the reliability of the individual predictors. This happened to compute the marginal reliability by using the standard error of measurement. The same exact things we had before are still available here. This is how you run a linear regression model using PACER. Notice PACER has some other options for the variance estimate. What I could do is I could choose the cluster robust, or CR, in order to get standard errors that might reflect a different sampling structure. When I choose CR, it's asking me to choose my cluster variable. Let's choose school ID. And now let's run the regression. Notice my standard errors are now different. The estimates of the fixed effects are the same as they were before. However, my standard errors are now cluster robust standard errors. We could also choose heteroscedastic robust or SRS for simple random sample. Once I run the regression model, there are things that I can export, and I can choose this drop-down menu. I can export the residuals, the predicted values, and the variance-covariance matrix. Simply choose one of them and click on Export Regression Model. They will be downloaded to your screen. Now, let's move over to a mixed effects model, or what some people refer to as a hierarchical linear regression. Remember, these data formed a hierarchical structure. The rows are the students, and we also have a teacher ID and a school ID. Let's run a very basic hierarchical linear model. First, let's ignore the measurement error. I'm going to click No. And now I'm going to choose a mixed effects model. Here, we need to choose how our data are structured. So let's choose our level variables. Let's choose school ID or SCHID as our level 2 variable. So now I have the rows, or my students, which represent level 1, and school ID, which will represent level 2. For those of you that are familiar with ML, or maximum likelihood, or REML, restricted maximum likelihood, you choose between the two options by clicking either ML or REML. Let's leave REML as the default and click Run Regression. It is now running a hierarchical linear model, and we're done. The first thing I see are the estimates of my fixed effects, the standard errors, and the t-value associated with the parameter estimate. I now have my variance components, the variance between schools, and the standard deviation, and the residual variance. I also have my fit statistics, the REML criterion, the number of iterations it took for this model to run, and the pseudo R-squared. If I come over to regression model plots, I also get the theoretical QQ plot, and I get a plot of my variance components. Another useful feature here is I can plot the empirical Bayes estimates of the school ID. Here, we can get a QQ plot of the empirical Bayes estimates, and I get a sample of the empirical Bayes estimates with their posterior variance, and this is just a random sample sorted of those available in the school ID variable. Suppose I want to estimate a model that's a little bit more complex. Let's refer to that as a 3-level model. Let's now choose teacher ID and school ID. This will now run a 3-level hierarchical linear model. We click Run Regression, and of course we see that the model is running because it tells us here. And as we wait, which was pretty quick, we now get the same screen printed, our parameter estimates, our variance components for the teacher ID, the school ID, the residual variance, the fit statistics. It took 39 iterations. All right. And over here, we get the regression model plots. I can choose the teacher ID empirical Bayes, and it will produce a QQ plot of the teacher empirical Bayes estimates, and I will also see a plot. I can also export the empirical Bayes here, just by clicking this, and this will send the empirical Bayes at level 2 to my computer, or I can choose the empirical Bayes at level 3 and send them to my computer. That's it for running linear regressions in PACER. It's extremely easy.